Each year, the Australian dairy industry contributes $13 billion to the economy through farms, manufacturing and exports. 1.74 million dairy cows across 8 dairy regions produce over 9,700 million litres of milk a year. Since the early 1990s, the industry has been intensifying, utilising higher levels of inputs to produce more milk. Looking ahead to 2040, with projections for a warmer and more variable climate, this pathway may not be the most viable option. In order to explore this concept further, Dairy Australia, together with the Australian Government, the University of Melbourne, the Tasmanian Institute of Agriculture and DARM Consulting, conducted research which set out to explore how 3 different dairy farm systems, located in central Gippsland, the Fleurieu Peninsula and northwestern Tasmania, might perform under predicted climate changes out to the year 2040. The 3 farms that were studied were seen as a representative dairy farm within their region. 2 of these farms, central Gippsland, Victoria, and the Fleurieu Peninsula, South Australia, were dryland dairy businesses. The 3rd in northwestern Tasmania was an irrigated dairy farm. The predicted climate for 2040 was biophysically modelled using high, medium and low climate change scenarios. The modelling looked at historical and predicted climate data and posed the question, how different is the climate likely to be and what current location would it most be like? Researchers also investigated how a changed climate would affect pasture growth in each location. Pasture growth underpins every dairying region, as this is the main feed source for cows. From the modelling, the case study farm in Gippsland was most likely to see an increase in temperature of 1.4 degrees Celsius and a 12% reduction of annual rainfall. This would make the predicted climate more like Cobden in southwest Victoria, but a bit warmer, or Talangatta in northeast Victoria, but with slightly less temperature extremes. For northwest Tasmania, temperatures will be more like southern Victoria, with rainfall very difficult to predict, whilst for South Australia, the predicted climate for the case study farm will be more like a location that is 40 kilometres to the north. Working groups made up of farmers and farm consultants guided the research in each region. Social researchers conducted interviews with dairy farmers and hosted focus groups to explore the social impacts on farm production from a changed climate. Most importantly, farmers interviewed were generally confident to adapt to incremental changes in climate based on their past experiences of adapting to variable seasons. In each case study, the existing farm system was tested in a 2040 high, medium and low climate change scenario. The scenarios were modelled using 3 development options: intensify, adapt and simplify. Each of the development options meant different things at the 3 case study locations. In general, the intensify options involved more cows, more purchased supplementary feed and capital investment in infrastructure. The adapt options involve changing the mix of resources without major capital investment. The simplify options generally involved less cows and less purchased supplementary feed. Put simply, the research did not find a clear winner in the form of the most resilient farming system for the future. All of the development options had both positive and negative aspects. Under all 3 development options, the profitability of the dairy farm businesses were negatively affected by the 2040 climate scenarios. In general, the adaptive or simplified farm production systems tested were considered to be realistic alternatives to the long-term trend of intensification. It isn't a clear-cut decision, as there are other factors which influence business performance. Firstly, milk payment systems may alter the attractiveness and returns of the different production systems, but milk price is likely to have a greater impact on business performance than climate change. Secondly, this research has shown that year-to-year climate variability is more of a challenge to dairy farm businesses than the effects of a predicted climate change out to 2040. Thirdly, the growing season for pastures will shift under these climate change scenarios, creating feed challenges. Dairy farm managers will need to continue to adapt their farm systems to manage risks presented by future climate. Finally, skilled farm managers are essential to the future success of the dairy industry. Regardless of the development options, intensified, adaptive, or simplified, considerable training and support for farmers and the industry will be required in the future, so that we can manage the challenges posed by the changes to the industry, the changes to the seasons, and the changes to the climate.